Use the Taylor series test to find the exact value of the series summation n going from 0 to infinity of minus 1 to the n times 2 pi quantity to the n plus 1 over 2n plus 1 factorial times 3 to the 2n plus 1. This is kind of a horrifying looking series right here, but the whole idea of the Taylor series test is to use the heredity principle. So let's start by writing out what this series is so we might recognize it a little bit better. So we're going to have 1 times 2 pi to the 1 over 1 factorial times 3 to the 1. That's when n is 0. When n is 1, we're going to have negative 1 times 2 pi to the 3 over 3 factorial times 3 to the 3. When n is equal to 2, we're going to have minus 1 squared, or 1, times 2 pi to the 2 plus 1, 5, over 5 factorial times 3 to the 5. The next term, when n is 3, we'll have minus 1 cubed. Then we'll have 2 pi to the 3 plus 1, or 7, over 7 factorial times 3 to the 7th. And then the next term will be negative 1 to the 4th power, so positive 1, 2 pi to the 4 plus 1, 9, over 9 factorial times 3 to the 9, and so on. So hopefully we can find the pattern from this thing right here. If we clean this up, we've got 2 pi over 3, and there's a 1 factorial out in front. Then it's minus 2 pi cubed over 3 factorial, 3 cubed, plus 1 over 5 factorial, or 2 pi to the 5, sorry, over 5 factorial, 3 to the 5, minus 2 pi to the 7 over 7 factorial times 3 to the 7, plus 2 pi to the 9 over 9 factorial times 3 to the 9. So we can go and generate as many terms as we want from this series right here. And the question is, do we recognize it? Now, one of the things about a Taylor series is that they have only one term, an x to the nth power in them. And so let's rearrange this guy a little bit by noticing the fact that these 2 pi's over 3's are always lumped in the same powers right here. So we could rearrange this as 1 over 1 factorial times 2 pi over 3 to the first power, minus 1 over 3 factorial times 2 pi over 3 cubed, plus 1 over 5 factorial times 2 pi over 3 to the 5th power, minus 1 over 7 factorial times 2 pi over 3 to the 7th power, plus 1 over 9 factorial times 2 pi over 3 to the 9th power. Now, since we have one expression in powers, let's call it x right now. So we'll replace 2 pi over 3 with x, and so this becomes 1 over 1 factorial times x, minus 1 over 3 factorial times x cubed, plus 1 over 5 factorial times x to the 5, minus 1 over 7 factorial times x to the 7, and all the way down the line. The upshot is that this series right here is nothing more than the Taylor series for sine of x. And sine of x has an infinite radius of convergence. And so that means any value can be plugged in and the series will work. So if we replace x by 2 pi over 3, we see that this series converges to the sine of 2 pi over 3, which is something we could work out real fast. That's a 120-degree angle. And so if we draw a quick triangle with a 60-degree reference angle, there's a root 3 here, a 1 here, a 2 here. The sine is the opposite over the hypotenuse. That means it sums exactly to root 3 over 2. And there's the exact sum of this infinite series.